This is the activity on playing with numbers. The objective of this activity is to construct a 3 by 3 and a 4 by 4 magic square. Now let's first understand what is the concept behind a magic square. So a magic square will have equal number of rows and columns. Like here you can see 1, 2 and 3 rows and 1, 2 and 3 columns. So this is called a 3 by 3 matrix. Likewise, you can have a 4 by 4 matrix. What we need to do is to write one number in each box. Like let's write from 1 to 9 in the 3 by 3 matrix. So I'll start with 1 here, 2 here, 3, 4, 5, 6, 7, 8 and 9. Now if you watch carefully, if you add the 3 numbers in the first row, it will add up to 15. Add 3 numbers in the second row, they also add up to 15. Likewise, the third row adds up to 15. The first column, the second column, the third column, all of them add up to 15. And this is not all. The diagonal, that means 8, 5 and 2, that also adds up to 15, and the other diagonal, this also adds up to 15. This is what we call a magic square. So we have 4 by 4 magic square where you will have 4 rows and 4 columns, and you will be putting numbers which are 16. Like you can put numbers from 1 to 16 or starting from any other number. You can choose 16 numbers, but they have to obey the same property. The sum of the numbers along each row, along each column and along each diagonal has to be same. For performing this activity, the material required is craft paper, glue and geometry box. So let's try and understand this amazing activity of 3 by 3 and 4 by 4 magic squares now.
In this activity on drawing a 3 by 3 magic square, let us suppose that the sum of numbers along the rows, the columns and the diagonals has to be 27. 27 divided by 3, because there are 3 rows and 3 columns, is 9. So we write 9 in the middle of this matrix. So 9 occupies this space, and now see what we have done. We have added a 1 by 1 cell on each center of the line. Like on the top, we have in the center another cell here, another one here and another one here. Now the middle number will be 9. So on the left and right, we will have 4 numbers on the left and 4 on the right. So we will have a total of 9 numbers. So what are we going to do now is we will write the numbers on the left 5, 6, 7, 8 and number on the right 10, 11, 12 and 13. How do we write that? We will write them diagonally. So 5, 6, 7, 8, 9 is already there. So 10, 11, 12 and 13. This is how you write diagonally all the numbers, and then you swap it. This 5 goes here. So this becomes 5. This 13 goes here. So this becomes 13. The 7 goes here. So this becomes 7. And the 11 goes here. So this becomes 11. And rest of the numbers 6, then 10, and then 8, and then 12, they remain the same. And look at this. This is a magic square of 3 by 3. Similarly, when you have to do a magic square of 4 by 4, let's take all the multiples of 4. So I'll start with this 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60 and 64. Now is it a magic square? Not at all. It is not a magic square. How does it become a magic square? Look at the diagonal. This diagonal 16, 28, 40 and 52. You will have to write the diagonal in the reverse order. So if I consider another 4 by 4 matrix here like this. Then the 16 on the top comes here at the bottom, followed by 28 here, then 40, and then the last one 52. And the other diagonal 4, 24, 44, 64, that also becomes reverse. So 64, 44, 24 and 4, and rest of the numbers 8, 12, 20, 36, then here we have 56, 60, 32 and 48 retain their places, thereby giving a 4 by 4 magic square. Now this is how we construct a 3 by 3 and a 4 by 4 magic square, which completes our activity.